Back to Excel, what fun. So our end product here that we need to find is how big do we need to make that? What's the cubic meters the volume that we need in there for our reduction of the BOD that we see in our problem here. And so largely we need two things. We need a residence time in, and we can do that in hours, or we could do it in seconds, whatever. We have an existing flow in meters per second. We need a particular residence time for our bacteria to do their job, and we can do it in days or hours, but we're going to do it in hours. We're going to eventually get to hours anyway, and we have some initial information. We have 0.15 meters cubed per second, existing BOD of 84 milligrams per liter. We have a growth constant of 100 milligrams per liter. We have a maximum growth of 2.5 per day. That's unitless. We have a food to biomass ratio of 0.5 milligrams per volatile suspended solids. We have a half velocity constant of 100 milligrams per liter. We have a decay rate of our macros is 0.05 per day, 5% per day. And that's 0.63. It says percent should be proportion. As we come over here, and let me see if I can slide over without my screen is too small. There we go. The BOD of the suspended solids is 60% of the suspended solids, and that gives us that, and that's our first step. All right, and the BOD allowed is 30 milligrams per liter. The BOD from the clarifier, $30 milligrams per liter. We want it to get down to 11 milligrams per liter, and these are okay. So that is our 63% of our reduction. So that our effluent quality has to get down to 11.1 milligrams per liter. And that's simply the BOD allowed minus the BOD5 times proportion times the BOD from the clarifier. And then that gives us where we need to go. Here, the solution they do here is they give the 11.1, and then they use the monads to get partway there. And so we're going to bounce over here, and this is our mean cell residence time. I simply solved down here. You'll see that equation down here. I solved for that instead of doing it with the numbers. I solved for it in terms of the variables and plug those in. I'm not going to walk through this equation. It is the equation that we use from here. You can see it there. It's slightly varied, and then so that's the residence time in days. Our mixed liquor volatile suspended solids is 2,000, and so we need that to do our residence time from T0. Again, it's another equation that we pull from the book and simply pump those in. It would be pretty valuable, actually. As you might notice, I've got most of the items up here, but it would be pretty valuable for you as an exercise to go through and find the basic variables up here. And for the most part, I've put them in the beginning. So that gives us 072 days, which we just convert from days to hours. It's 1.75 hours. And that gets us what we needed, which was our residence time in hours times the flow, and turn that from seconds into hours, and that's 945 meters cubed. So if that sucker is 2 meters deep, don't want to get much deeper than that. It's 472. So um, so that's square root of 472. So this thing is roughly 20 meters by 20 meters, or 40 meters by 10. So this is consistent with what we just saw in another size. But and the one we were looking at was substantially larger than that, meaning that it probably had a much bigger flow into that plant, the one we looked at just a second ago.